Hello and welcome to Add-on. So today we will learn about the difference between type 1 and type 2 superconductors. So have you ever wondered why some materials completely resist magnetic fields and others just sort of let them in a little? So let's understand this. So first let's talk about Meissner effect. So it's the key feature of superconductors where they expel magnetic fields completely below a certain temperature. So the type 1 superconductors do this perfectly. So they then don't let any magnetic field inside, which makes them what we call perfectly diamagnetic. So think of it like an invisible shield around a material that pushes the magnetic field away entirely. So now, what about the type 2 superconductors? Well, the type 2 superconductors, however, are a bit of different. So they don't fully repel the magnetic field. Instead, they let some of it penetrate in small concentration region called as vortices, and they are not perfectly diamagnetic for that reason. They only show a partial Meissner effect. So type 2 superconductors uh, uh, allows partial magnetic penetration. Next, we classify type 1 superconductors as soft superconductors and type 2 superconductors as hard superconductors. But don't think of it as actual softness or hardness like a pillow or a rock. This is just terminology used to describe how they interact with the magnetic fields and other characteristics. So the type 1 materials tend to lose their superconducting properties easily when exposed to a stronger magnetic field, while type 2 superconductors can handle much higher fields. Now here's a crucial difference, which is the number 3. The type 1 superconductors has only one critical magnetic field. If the applied magnetic field goes beyond this point, the superconductor loses its properties and becomes a regular conductor. Whereas the type 2 superconductors have two critical magnetic fields called as lower critical field and upper critical field. Between these two values, something interesting happens. So the material lets some of the magnetic field lines penetrate it, forming those vortex lines we mentioned earlier. But above the upper critical field, it completely loses its superconducting state, just like type 1. So now we have the fourth point, which is a material in type 1 superconductors loses the magnetization abruptly. Imagine switching off a light, it's either on or off, no in between. But with type 2 superconductors, this change is gradual. Their magnetization decreases slowly as the magnetic field increases between the two critical values, like dimming of light. So this gradual loss makes type 2 superconductors very useful in high field applications. Now lastly, let's look at the examples of type 1 superconductors, which are lead, tin and mercury. These are more classic superconductors you might think of. On the other hand, we have type 2 superconductors, which are usually alloys or compounds like niobium and tin, niobium and titanium, which can handle much higher magnetic fields. So to sum it up, we have 5 main differences. The first is Meissner effect, softness versus hardness, critical magnetic fields, and how they lose magnetization, and the examples. So type 1 superconductors are classic single-field, perfectly diamagnetic materials, while on the other hand, we have type 2 superconductors that are hard, multi-field, and partially diamagnetic. Right. Thank you for watching.